students, in this video I am explaining a problem with various conditions of frictional force. I hope that you got ideas and various concepts of friction from my previous videos. Here, a block A of mass m is placed on a horizontal table. Another block B of mass small m is placed on block A as shown in figure. Now F force is applied on A. Now the first condition is that there is no friction between all the surfaces. And we have to calculate the time required to travel block B over block A. If we draw the free body diagram here of block A, only external force F is applied. There is no frictional force. Then the acceleration of block A, that is A, is F by m. As the force is applied towards right, then acceleration of block A is also towards right. If we consider block B, there is no force acting. Therefore, block B remains at rest with respect to ground. But if we consider block B with respect to block A, then block B moves towards left with the same acceleration of block A. Therefore, if we consider the motion of block B or acceleration of block B, with respect to block A, this is equal to acceleration of B, this is F by m, but direction is towards left. If L is the distance traveled by block B for time t, then we can write that L is equal to half ABT square, or L is equal to half F by m t square. Therefore, time required here, this is t, is under root 2 Lm by f. In the next condition, there is a friction between the surfaces of block A and B only, and the coefficient of friction is mu. There is no friction between the block A and the table. Now, if we consider the free body diagram from block A, then F force is applied here, and the motion of block A is towards right. Therefore, the frictional force applied on the upper surface of block A by block B is towards left. And there is no friction between block A and table. Therefore, block A can move whenever the applied force is greater than the frictional force. If we consider block B, it experiences a frictional force by block A towards right. Mg is the weight of block B, R is the reaction force, then frictional force F is equal to mu into R. This is mu mg. This is the limiting friction. Between block A and B. Now, if we consider A and B as a system, then the frictional force are acting here. This is the internal force, and only external force is applied on the system. And this system is placed on a table which is frictionless here. Therefore, the acceleration of the system this is A, this is force by total mass of the system. Now, whenever block A is moving with acceleration A, therefore block B, which is placed on block A, it also experiences a pseudo force. The pseudo force is acting here. This is F prime. Here the pseudo force experienced by block B is F prime. This is mass into acceleration. So this is F m by m plus m. If block B remain on rest on block A, then the frictional force acting here, this is greater than the pseudo force, that is F prime. Therefore, F prime is less than mu mg, and F prime, this is Fm by m plus m less than mu mg. Therefore, F less than mu g in bracket m plus m. So this is the condition. If the external force applied here F, which is less than mu g into m plus m, then both the block will move with same acceleration. If the applied force F is greater than mu g in bracket m plus m, then both blocks are moving with different accelerations. For free body diagram of block A, F is the applied force, frictional force in opposite direction. Therefore, F minus F, this is the net force. This is mass into acceleration of A. Therefore, MA, this is F minus mu mg. Actually, mu mg, this is the limiting friction. Therefore, acceleration of block A, this is F minus mu mg by m. This is equation 1. For free body diagram of block B, the frictional force acting here, this is towards right. This force is applied by block A on block B. Then for block B, the net force, that is F, this is m, the acceleration of B, or this is mu mg. Therefore, acceleration of B, this is mu g. This is equation 2. Here two blocks are moving with different acceleration in same direction, that means towards right. Now, if we want to calculate the time required to move block B over block A, then we have to consider the relative displacement of block B with respect to block A, and we need the relative acceleration of B with respect to A also. So, acceleration of block B with respect to A, acceleration of B minus acceleration of A, is mu g minus F minus mu mg by m. Negative sign indicates that B accelerates backwards with respect to A. If L is the length traveled by block B over block A for time t, then L is equal to half acceleration of B with respect to A into t square. Therefore, T is equal to under root 2L by ABA. In next condition, there is a friction between block A and table. The coefficient of friction between block A and table is mu prime. If you consider the free body diagram here, this is block A, F force is applied, there is a friction between block and table, and this is F prime. Here F prime, this is mu into m plus m g. Whenever block B is on block A, mg is downward, R is the reaction force here. Here R is equal to mg. And for block A, the force applied by block B is downward, this is R, and a reaction force is acting here by the table on block A, this is N, and mg is the weight acting here. For that reason, N is equal to R plus mg, so N is equal to mg plus mg. Therefore, F prime is equal to mu into N. For that reason, this is mu m plus m into g. Now, what is the acceleration of block A? Acceleration this is A f minus f prime by m. This is f minus mu prime m plus m g by m. Now, if the surface between block A and B is frictionless, then acceleration of B is equal to minus of acceleration of A. Then the time taken by block B to move over block A, this is L is equal to half ABT square. Therefore, T is equal to under root 2L by AB. If there is a friction between block A and B and the coefficient of friction between block A and block B is mu. If we consider the free body diagram for block B here, as block B is on block A and block A is moving with an acceleration, therefore block B experiences pseudo force. This is F prime. Here pseudo force F prime is equal to m into acceleration of A. This is m F minus mu prime m plus m g by m. Now, due to the pseudo force, there is a frictional force acting on block B in this direction. This is F prime, sorry F, and this is equal to mu mg. This is the limiting friction. If block B is at rest, then frictional force is greater than the pseudo force. Therefore, mu mg greater than m in bracket f minus mu prime m plus m g by m. So mu g greater than f minus mu prime m plus m g by m. This is the condition whenever block B is at rest. When block B moves over block A, then the pseudo force is greater than frictional force. Therefore, m in bracket f minus mu prime m plus m g by m is greater than mu mg. Therefore, f minus mu prime m plus mg is greater than mu mg. So, f greater than mu mg plus mu prime m plus mg.